Welcome back, everyone. Today we will be talking about digital and sustainability. Two seemingly distant things, but can be quite challenging for us nowadays. So what makes digital technologies unique? If you look at this map, this was a map drawn by Randall Munro back in 2007. The map represented the most popular online communities back then as islands and continents, and land size was based roughly on the number of users of each service. But if you look very carefully at the map, you will see that most of the things there will not exist anymore. For example, MySpace was no longer exist, Friendster was no longer exist, but on the other hand, Facebook is now becoming bigger and be the market leader in our online communities. So what I want to say here is that when we are talking about digital world, things can happen very quickly. So how do we define digital innovation? Digital innovation is actually the creation and consequent change in market offerings, business process, or models that result from the use of digital technology. When we are talking about digital innovation, it can include a range of innovation outcomes like new products, platforms, services, user interface, and so on and so forth. It can also involve different range of digital tools and infrastructure that make innovation possible, like 3D printing, data analytics, mobile computing, artificial intelligence, machine learning, and so on and so forth. And we should also think about possibility that outcomes may be diffused, assimilated, or adapted to specific use contexts, such as typically experienced with digital platforms. So what makes digital innovation different? If we look back at the old fundamental assumption of innovation, usually innovation is a well-bounded phenomenon focused on fixed product. The nature of innovation agency is centralized. Innovation process and outcomes are distinctly different phenomena. Those are the fundamental assumptions of traditional innovation or non-digital innovations. But with digital innovation, everything has changed. So let's look at the first assumption. Innovation is a well-bounded phenomenon focused on fixed product. The fact is that it is no longer true because most digital designs remain somewhat incomplete and in a state of flux. In digital innovation, we have to deal with unprecedented level of unpredictability and dynamism. In digital innovation, we have to think about the boundaries between different organizations because everything has become more porous and fluid. Innovation process and outcomes have also become less bounded in terms of their temporal structure. It is also unclear for us to distinguish between the start and the end of innovation phase. And innovation process usually unfold in a non-linear fashion. Because of that, we need to think about new success criteria as well as new underlying factors that different compared to non-digital innovation. So on the left-hand side is Google when it was started in 1998. On the left-hand side is Google today. Can we say that Google on the right-hand side is the final product? No, because even today, probably they are still modifying or updating their algorithms in order to make their search results better. So it is difficult for us to say that on the left-hand side is the start and on the right-hand side is the M, it is difficult for us to say that Google on the right-hand side is the final products. The second assumption is that the nature of innovation agency is centralized. Again, this assumption is no longer valid because we can see the shift toward distributed innovation, open innovation, and network-based innovation. And because of this, we have to deal with different set of actors. Different set of actors mean diverse goals because they have different motive, different interests, and so on and so forth. And such arrangement can opt in and opt out whenever they want, when their goals change, when new competencies are needed, when their motivation shifts, or when they found new constraints and opportunities, or because of many other reasons. So they can come in and they can go anywhere they want. The most important thing here is that digital platforms and open standards enable us to pursue innovation collaboratively. Let's take a look at this business ecosystem of Apple. If you look at this figure very carefully, you will see on the top right corner, there are many technology companies like Intel, AMD, NVIDIA, Samsung, ARM, and so on and so forth. But on the right-hand side, you will also see different companies like Sony, Sega, EMI, Capcom, Buena Vista, and so on and so forth. They are coming from media and entertainment business. On the bottom of the figure, you will see companies like QLogic, Belkin, and Bose, for example. They are focusing on multimedia and entertainment. On the left-hand side, you will see Microsoft and Google. This is also interesting because in some market, Apple and Google and Microsoft are competing each other. But here, they have to work collaboratively. And on the top left corner, you will see universities like MIT and von Humboldt University. So this figure illustrates that business ecosystems nowadays can be quite diverse. It can be consist of different collection of actors that have different motives, different interests, and so on and so forth. It is not like what happened in 1990s or 1970s, where business ecosystems tend to be similar and comes from relatively same industries. Now, the third assumption is that innovation process and outcomes are distinctly different phenomena. With digital innovation, this is no longer true because we can see dependencies between innovation processes and innovation outcomes as a complex and dynamic process. And because of this, it can generate multiple waves of innovation, unexpected interaction and collaboration between different stakeholders. And because of this, innovation processes and outcomes are shaping and being shaped by the other. For example, if you want to design a house, architecture company or design company will use the technology like 3D printing or virtual reality. Those kind of technology will then being adopted by other industries, like, for example, in construction industries. And then as soon as your house has been built, then other companies like utility companies and so on and so forth can also adopt similar technologies. So essentially, what happened in a particular sector or particular industries will also affect what happened in other sector or other industries as well. This is an example of a gadget that was quite popular back in late 90s or early 2000. It is a USB flash disk equipped with a speaker, music player, as well as a small microphone. So you can use it as a music player. You can also use it as a recorder. You can also use it as a data storage. But then this kind of innovation is being adopted by Apple. They develop iPod Nano and their ecosystem to be one of the market leader in music industry. This kind of technology is also being adopted by storage company like SanDisk, Western Digital, and so on and so forth. Because by adopting this kind of technology, they can develop new USB flash disk with bigger capacity and better performance. So what happened in a particular sector or what happened in a particular industry will eventually affect other industries as well. Because of this, the logic of digital innovation can be quite different compared to the logic of non-digital innovation. Because in digital innovation, we have to focus on dynamic problem solution design. We also have to think about socio-cognitive sense making. So we are not only focusing on the technology or the tools or things like that, but we also have to think about the social aspect and behavioral aspect of the technology as well. And then technology affordance and constraint, because by adopting new technology, it can make so many things become possible. And finally, it will require a kind of orchestration capability, because you will have to deal with different set of actors with different interests and motives. So it means that you have to be able to make sure that everything works together. Imagine that you are a big company like Apple. You have to make sure that you can work together with Samsung, with Microsoft, with Google, with Sony Music, with EMI, and so on and so forth. And those kind of things can be very, very challenging to do. So what makes digital innovation can be difficult and challenging? The main reason for this is that we have to deal with physical materiality as well as digital materiality. Physical materiality are the artifact that can be seen, that can be touched. Usually it is fixed, it is difficult to change, and it connotes a sense of place and time. On the other hand, we also have to deal with digital materiality. It means that we have to deal with software that being incorporated into the physical artifact. Because of this, we can manipulate our digital representations. And the entanglement between physical and digital materiality can be very complex and difficult to anticipate. So what is digital technology? The fundamental properties of digital technology are two. The first one is reprogrammability or von Neumann architecture, and the second one is data homogenization. Reprogrammability or von Neumann architecture means that everything can be programmed, everything can be changed, everything can be manipulated. Data homogenization means that everything has now been converted into discrete representation of binary code of 0 and 1. And because of this, we have to appreciate the capability of technology that can make everything becomes affordable. For example, back in 1990s, it is very difficult and expensive to make a phone call abroad. You have to dial a specialized number. You have to pay for quite expensive rates, and the quality of the communication is not as good as now. But if we move fast forward to today, making phone call abroad is very easy, because we can use Skype, we can use video call, we can use Zoom, or many other different technologies that enable us to make communications with anyone, everywhere, easily, and even free of charge. The quality of the communication technology is also better, because you are not only hearing the voice, but you can also see the visual representation of the person that talked to you. So this is the von Neumann basic structure. Essentially, you have the input, you have the processing unit, and you also have the output. The processing unit will consist of CPU or central processing unit and memory unit. Processing unit is where the calculation happens or the processing happens. Memory unit is where the result of that calculation process is being stored. Any digital device nowadays is following von Neumann basic structure, whether it is a computer, whether it is a laptop, whether it is a gadget, whether it is an iPad, whether it is a mobile phone, anything, it is essentially follow the von Neumann structure. For example, in a computer, we can use keyboard as an input. We can also use microphone as an input. We can also use our mouse or our camera as an input. Those kind of things will convert everything into binary code being processed in a central processing unit and then store the data in a memory unit. And after that, everything is then being sent to the output device. In a computer, output device can be your screen. It can also be your speaker. It can also be like an LCD projector or a printer and so on and so forth. And this is what I mean by data homogenization. So essentially, everything that you type in your computer, everything that you write in your computer, or everything that you record on your computer will be converted into binary codes like this. And after they were being converted into binary codes like this, then manipulation is easy peasy lemon squeezy. And if you combine the von Neumann architecture and data homogenization, then hypothetically, you can do anything. As long as you have enough computing power, then you can do any calculation, any manipulation, any programming, and so on and so forth. That's the basic fundamental of digital technology. Now, what are the results of this von Neumann architecture and data homogenizations? Essentially, the result of these two fundamental aspects of digital technology are convergence and generativity. What is convergence and what is generativity? Convergence means bringing previously separate user experience. So previously, if you want to watch football match, then you have to turn on your TV. If you want to make a phone call, then you have to dial your telephone. But nowadays, you can do everything using your mobile phone. Using mobile phone, you can make a call with your friends. You can also watch football match from your mobile phone. You can also text your friends. You can also write documents. You can also make a video and things like that. So bringing previously separate user experience into one device or one tools is called convergence. Convergence also means that it is embedded into previously non-digital physical artifacts. This is what we call by smart technology or smart products. Let's say you have a fridge, refrigerator. It is relatively traditional technology, non-digital technology. But if you put a kind of IoT sensors, Internet of Things sensor, and if you connect your fridge into the internet, then it becomes smart fridge. If you have a TV and then you connect them to the internet, you put sensors on your TV and so on and so forth, then it will have a capability as a smart TV. So basically, by putting this digital technology into previously non-digital physical artifacts will create what we call by convergence. And finally, we can also bring together previously separate industries like Skype, Netflix, Gojek in Indonesia, and so on and so forth. It is very difficult for us to classify whether Skype is a technology company or a communication company. Should we categorize Netflix as a media and entertainment company or a technology company? Should we categorize Gojek, for example, as a transportation company or a finance company or a technology company? It is very difficult for us because they are operating in different sectors and different industries at the same time. To give you an illustration on this kind of convergence, then please take a look at the following graph. According to this figure, then the main income of Apple was coming from iPhone. because 62% of their income was based on the sale of iPhone. And the revenue from the sale of their computer products was only 9.6%. So because of this, essentially, Apple is an iPhone company. Let's take a look at Facebook. Almost 100% of their income was coming from Facebook ads. And if you look at the comparison on the right-hand side, then the revenue per user for Facebook is $35 compared to Netflix that only $30. You know that Facebook is free, right? And Netflix is paid membership. You have to pay for subscription fee for every month and so on and so forth. But the interesting thing here is that revenue per user for Facebook is higher. It means that you are essentially the product. Now let's take a look at Microsoft. Microsoft is relatively very well diversified because about 25% of their income coming from Microsoft Office, about 70% coming from Microsoft Windows, about 23% was coming from Microsoft Azure, and the remaining incomes came from LinkedIn, enterprise services, Bing, Xbox, and so on and so forth. So Microsoft is relatively well diversified compared to other technology companies. Now let's take a look at Amazon. In Amazon, it is quite interesting because about 52% of their income was coming from online stores. But the growth of their third-party services is also remarkable. The significant increase in Amazon Web Services is also interesting to look at. It is also interesting to see other services like Amazon Prime and their physical stores that growing very rapidly in the last couple of years. Now, consequently, even though Apple, Facebook, Google, Amazon, and Microsoft are technology company, Apple is mostly an iPhone company. Facebook is an advertising company. Google is an advertising company. Amazon is mostly a store and marketplace, even though they have also different services at the same time that are growing very rapidly. And Microsoft is diversified. So what are the consequences from this kind of innovation? The thing that we have to realize is that when we look at the corporate strategy, we have to understand what drives the company's revenue, especially in the digital economy, because revenue can come from many different sources. It is not like what happened in traditional industries or traditional companies. If I have a coffee shop, then my revenue will be mostly coming from the sale of coffee cup. But if I have a startup company, then the possibility for me to gain revenue can be diversified. There are many options for me to gain revenue from the customers. Now, what is generativity? Generativity means procrastinated binding of form and function. For example, if you buy a mobile phone, then it is not a finished product because as soon as you get your mobile phone, you can insert new capabilities. You can install new application, you can change the theme, you can add music, you can install new application and so on and so forth. Even though you already bought the products, new capabilities can be added after produce, even couple of years after you purchase that products. And it can manifest it in the ways of innovation, like I mentioned earlier. If in an architecture company is implementing 3D visualization, then it can also be adopted in a construction project. And 3D printing will also be adopted in prototyping the manufacturing. So what happened in a particular sector or particular industry will also be influencing what happened in other sector or other industries. And finally, and I think this is the most important thing here, is that it will leave unprecedented volume of digital trace as byproduct, or derivative innovation. This is what we call by big data. For example, if I have a smartwatch, I like to run every morning, then I can use Strava, for example, to record how long I ride, how many energies that I burn, how many calories that I get, and so on and so forth. And if Strava can collect the data from me, then Strava can also collect data from other users. And if they collect data from thousands of users or million of users, then they can have enough data to analyze, to develop new services, or even to create new algorithm and so on and so forth. So the possibilities are endless. Now, what are the consequences? What are the implications? After everything is being converged, after generativity is everywhere, what are the implications? The first implication is that the digital platform is now becoming very important. What is digital platform? Digital platform is a building block that provides an essential function to a technological system, which acts as a foundation upon which other firms can develop complementary products, technologies, and services. This is not something new, but because of the digital technology, then the spread is hypothetically unlimited. For example, a traditional market is actually a platform because it is a building block that enable buyer and seller to meet and do transaction. In a traditional world, buyer and seller in that market usually comes from people who are live not far from the market. But in a digital world, buyer and seller can come from everywhere. That's why, hypothetically, the spread of digital platform can be unlimited. And firms nowadays innovate by creating platforms rather than single products. They will form a kind of ecosystem that includes heterogeneous actors like what happened with Apple that I showed you earlier. And by doing this, it will allow firms to build not only platform of product, but also digital capabilities throughout the organization. As a result of the emergence of digital platform, then we have to deal with balancing generativity and control, because too much control will make your user live, but too much generativity, too much flexibility, then it will risk your platform lose control. Another implication is that we have to deal with data sharing and process sharing across organizational boundaries. Again, we have to deal with privacy issues, security issues, and so on and so forth. And because of this, innovation activities will become increasingly horizontal. One thing that we have to be very careful here is that too much heterogeneity and boundless innovation will create chaos. The second implication is the emergence of distributed innovation. Distributed innovations means innovation is now becoming democratized. It distributed across different organizations and involve people or actors from outside of organization. And because of this, it will increase the heterogeneity of knowledge resources in order to innovate from specialized self-contained professions or industries. The implications are that knowledge resources will be heterogeneous and often temporarily integrated, changing dynamically in response to unpredictable changes from inside and outside firms' ecosystem. Innovation increasingly requires that others be enabled to innovate as well. We will also see the emergence of new industrial structures. And finally, it will also introduce new forms of risk, unintended consequences. And the third implication is the prevalence of combinatorial innovation. Combinatorial innovation is essentially creating new products or services by combining existing modules with embedded digital capabilities. Like if you combine shoes with microchip or sensor, then it will be new device that can track your position, your heart rate, your calories, and so on and so forth. The implication of this is that modularity is now becoming very important for combinatorial innovation. Companies need to invest in new forms of creativity. Ideas will not only spread following the traditional S-curve, but it will mutate and evolve as they spread. And finally, a heightened complexity of the innovation process is also increasing because we have to deal with heterogeneous modules, diverse actors, and we also have to anticipate systemic risks as well as the unintended consequences. And because of this, now companies must learn how to build and organize digital platform and learn how to carefully deal with fault lines. The question is, what does it has to do with sustainability? What is the relationship between digital technology, digital innovation, and sustainability? Let's take a break for a moment and we will come back into that question.